Hi, my name is Philip Franklin, and I'm going to be presenting you today with how concepts of using physics in the sport and activity of cheerleading. I chose the sport of cheerleading because I had a sister and several cousins that did cheerleading and competitions, and I actually have a niece right now that's in cheerleading. And so I thought it'd be a really cool concept on how to find how physics interacts with cheerleading. From various stunts and tricks that they use in their performances. And so I thought it'd be a really cool way. So what we'll be discussing today, I'm going to do a brief background on what is cheerleading and discuss cheerleading just in case some people didn't know what it was or the different roles that people play. And then I'm going to discuss three simple physics concepts that will be discussed into this PowerPoint. And then I'm going to give in-depth analysis and examples on how all three of Newton's laws are applied to cheerleading, and especially in some of their two of their basic stunts that they do. And then I'm going to give you an example of rotational inertia and how faster someone's inertia is when they don't tuck and when they do tuck, and how their inertia changes. Now, what is cheerleading? Cheerleading is a sport or organized team that tends to do chants, dances, or perform at various stunts at a sporting event or competitions. Some of the sporting events are basketball, football, sometimes baseball, just depends. And then for competitions, there are high school, AAU tournaments, and then you also obviously have college. And then the various stunts that a cheerleading team performs are known as the high basket toss and a high basket back tuck toss. So the first image on the right is going to be the high basket toss. I couldn't find an image where they started from the bottom of the moment of the movement and then moved up to where the flyer is now. But they begin by tossing the girl into the air from her backside, and then the girl will either stay on her back or tend to do a stunt or a trick. And then a high basket back tuck toss is going to be the image that is seen here below. And the individual is thrown into the air, and then she will tend to tuck her head or knees or both, and then rotate to make a flip or several flips. And then I just want to go over the roles of how a cheerleading group is. And so tend to be a group of 3 to 5 people. As you can see, it can be either girls or guys. It doesn't have to be either or. And then the person that's thrown into the air is known as the flyer. And then the group that is throwing and catching the flyer are known as the supporters. So those are going to be either the 3 or 4 people that are still on the ground tossing the flyer into the air. And here's a group of cheerleaders. Again, they're just doing some simple formations. And then as you see, the individuals on top are known as the flyers. And the group of girls of 3 to 4 down below that are holding them are known as the supporters. So the physics concepts that will be discussed are going to be Newton's 3 laws and then rotational inertia. And Sir Isaac Newton has 3 laws, and they are always implemented into cheerleading. And Newton's first 3 laws, I'm going to go over with Newton's first law. And Newton's first law states that an object that moves with a velocity with a constant, that is at constant, with a magnitude and direction, unless a non-zero net force acts upon it. So basically, what this first law is stating is that whether in motion or not, the object will move depending on, it will stay at rest or in motion unless another forces act upon it. And Newton's second law states that acceleration of an object is directionally proportional to the mass. And then Newton's third law states that an action results in a equal or opposite reaction. And I will be going in depth in all three of his laws right now. And we're going to start off with Newton's first law. For this example, for all three examples, we're going to stay with the high basket toss. And the flyer, when on top of the supporter, is remaining at rest at 0 meters per second. In Newton's law, it states that a object will stay at rest unless a force acts upon it. So the cheerleader will always stay at rest until the supporters begin to toss her, and that's when they will change her velocity or speed depending on if there's a direction applied to it. And so why is this? This is because the force that has to be applied will come from the supporters. That will change the velocity of the flyer, and then her velocity will remain constant while in the air until gravity acts upon it at the top of her trajectory. Because at the top of her trajectory, it tends to become 0 meters per second before gravity acts upon it, adding 9.81 meters per second onto her downward fall. And then here is Newton's second law. And again, like I said, we're going to stay with the example of the high basket throw. So the supporters will apply the force that will toss the flyer into the air, and that same force applied to the flyer will be directional proportional with its velocity of acceleration into the air. So in this example, we're going to find how her final velocity divided by the time in which it takes them to toss her into the air will give her acceleration. So the capital A is equal to acceleration, and then in this equation, A equals final velocity minus initial velocity over time. So we're going to say that her final velocity was 16 meters per second, and we're going to subtract it from 0 meters per second because her initial velocity before being thrown into the air by the supporters was her at rest, because since she was at rest, she was at 0 meters per second. And then divided by time, we use 2 seconds because this is how long it took the supporters to throw her into the air. And so if you take 16 meters per second minus 0 meters per second, that would be 16. And then you take 16 divided by 16 meters per second divided by 2 seconds, and then her acceleration would become 8 meters per second squared. Newton's third law, this is applied and it states that one action will result in an opposite or equal reaction. So staying with the high back toss again, if the supporters toss the flyer into the air, the force that was being applied to the flyer, the opposite force would then have to act upon it as gravity takes over and will apply that downward force back towards the supporters. And so it comes with the concept of what goes up must come back down. And so for the supporters to catch the flyer, they must absorb the force in which they threw her upwards, and so they could catch her downward force. If they do not absorb the catch or absorb the force in which the flyer comes down with, serious injuries could then happen to the flyer. And then here's an example of how Newton's third law is used. So force is going to be the capital F, and we're going to find that by using mass times acceleration. And so we're going to use the flyer having a 30 kilogram mass, and then we're going to use the acceleration that we used in the first example of 8 meters per second squared. And so all you do is do multiplication of 30 kilograms times 8 meters per second squared, and you will get force is equal to 240 newtons, or 240 kilograms per meter, 240 kilograms times meter per second squared. And newtons is the SI unit for force. Now I'm going to show you how we can find an example of rotational inertia during a flip. And the center of mass for the flyer is always going to be in the middle of their body, which will tend to be their stomach or hip region. And the lower and upper extremities will increase inertia as